Okay, hello everybody. Welcome to Mr. Morrow's algebra class. This class will be dealing with algebra 1 and 2, and we're going to go ahead and start things off with the basics. Today we're going to talk about fractions, decimals, and percents, part 1. It's a rather long section, and instead of just jamming everything into your brain and not really processing it correctly, I wanted to make sure that I took my time with this so you guys can really get the most out of it. In order to truly understand how to work with fractions, okay, you must realize that fractions, decimals, and percents are all different ways of writing the same value. Once you get that concept down, things become a little bit easier. Fractions, decimals, and percent values are part of a whole. Every single one of those are part of a whole. So 3/4 would be the fraction. It's 3 parts out of 4 parts. 0.75 would be the decimal conversion. That's 0.75. It's not a whole. It's part of a whole. And then you have 75%. And 75% is also not 100%. It's not one whole. It's part of a whole. Today we will learn how to simplify and find equivalent fractions, round decimals, and then in part 2 we will learn how to convert fractions, decimals, and percents. So that will be for tomorrow's lesson. For today, we're going to learn how to simplify and find equivalent fractions and round decimals. All right, so let's move on. In order to work with fractions, decimals, and percents, we have to go over some basics. Sorry, there should be a go here. We have to go over some basics. First of all, fractions. Fractions are part of a whole. Fractions are part of one whole and are written as follows. There's a numerator and a denominator. The numerator is on the top part of the fraction. Denominator is on the bottom part of the fraction. The fraction 2/5 is read as 2/5 and represents 2 out of 5 pieces which made one whole. So if I have a little pizza pie here, and I've got, for example, here I've got 1, 2, 3, 4, 5, 6, 7, 8 slices. 3/8 means that 3 out of the 8 slices were either taken away or left, or that's what that fraction represents. 3 out of a total of 8 to make one complete whole. Now let's go over some concepts and vocabulary before we get into the actual math. If you remember, factors are numbers that go into other numbers evenly without a remainder. Factors are always less than or equal to the original number. For example, the factors of 20 are going to be, whenever I have a list of factors, I always start with 1. And watch how I do it. It makes it very easy and neat, and the reader is very, very much understanding what you're writing. So how do I get 20? That's what I ask myself. What times what is 20? Well, 1 and 20. I always start with 1. Does 2 go into it? Yeah. 2 and 10. Does 3? No. 4? Yes. That's 4 and 5. 6? No. 7? No. 8? No. 9? No. 10 we already have. So we can clean it up. And the factors of 20, let's just go ahead and clean this up a little bit, are 1, 2, 4, 5, 10, and 20. Those are the only factors. Factors have a finite number to them. There's only a certain number of factors. They're not infinite. A prime number. Talking about factors, a prime number is a number whose factors are only 1 and itself. Believe it or not, 0 is not a prime, and the number 1 is not a prime, because 1 is itself. So what are some prime numbers? 2, 3, 5, 7, 11, 13, 17, etc., etc. Prime numbers are numbers whose factors are only 1 and itself. So the opposite of a prime number is a composite number. A composite number is a number that has more than 2 factors. A composite number is a number that has more than 2 factors. For example, let's say 9. 9 has the factors 1, 3, and 9. So that is a composite number. 9 is a composite number. Prime factorization. Prime factorization is the process of breaking down a number into its primes. For example, the prime factorization of 24 is, well, let's go ahead and write our number 24. Let's break it down. It doesn't matter what factors you choose, but choose 2 factors that go into 24. What times what is 24? I'm going to choose 3 and 8. I'm going to go ahead and circle 3 because that is prime. I'm done with that. 8 breaks down into 2 times 4, which I'm going to circle 2 because that's prime. I'm done with that. And then 4 breaks up into 2 and 2. So there you go. 3 times 2 times 2 times 2 is 24. So the prime factorization of 24 would equal 3 times 2 to the 3rd power because there were 3 2's being multiplied. So when you're talking about prime factorization, it's literally breaking down the number into all of its prime factors. A multiple. A multiple, let's move this guy over here a little bit. Sorry about that. Let's move this up here. Okay. Multiples, okay? Multiples are products of natural numbers, or whole numbers, or, okay, whole numbers and natural numbers. Multiples are always greater than or equal to the original number, and they're infinite. There's an infinite number of multiples. For example, let's just list the first 5 multiples of 4. How do we do that? You go 4 times 1, that's 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. ... That keeps on going forever. Multiples are infinite. Factors are finite. Hope that kind of jogged your memory a little bit. Let's continue. Now, let's put all of those concepts to play. Greatest common factor. The greatest common factor is the largest common factor between 2 or more numbers. If you know your multiplication tables and the divisibility tests for numbers, it is very easy to find the GCF of 2 or more numbers. What is LCM? LCM is the least common multiple. The smallest common multiple between 2 or more numbers is called the LCM. If you know your multiplication tables, it is very easy to find the LCM. Now, I keep saying it's very easy. Let me prove it to you. Let's find both the GCF and the LCM of 18 and 30. Let's go ahead and write a couple procedures here. Number 1, to find the GCF, okay, the GCF equals the product of paired primes. I'll explain what that means in a second. And the LCM is the GCF times, so multiplied by, times, I'm going to put in parentheses, left over primes. Okay? So the GCF is the product of paired primes, and the LCM equals the GCF times multiplied by the leftover primes. Let me explain what that means. I'm going to erase this. So let me explain what that means. Actually, let me not erase it. I'll just shrink it up a little bit. Okay, so we'll have that there on the side there, just to help us out. Okay, so we've got to find the GCF and LCM of 18 and 30. Okay, first things first. Go ahead and find the prime factorization for each of these. 18 breaks up into 2 times 9. 9 breaks up into 3 times 3. That is the prime factorization of 18. Let's look at 30. That's 3 times 10. 10 is 2 times 5. That is the prime factorization of 30. Now, I had said that the GCF is the product of paired primes. So let me explain what paired primes mean. So I'm going to list my GCF right here, and the GCF is going to equal. Okay, you see how there's a 2 under the 18 and a 2 under the 13? That's one pair. Every pair comes out as 1 of that value. So a 2 and a 2 comes out as a 2, times a 3 and a 3 comes out as a 3. Do I have another 3 in both? No. Do I have a 5 in both? No. So the GCF is 6. Nice and easy. The LCM equals the GCF, which in this case is 6, times the leftover primes. The leftover primes in this case are this 3 that didn't have a match, and this 5 that did not have a match. And that's how you find your LCM. So 6 times 5 is 30 times 3, so 90. So 90 would be your LCM, and 6 would be your GCF. I hope that made a lot of sense, guys. And then the least common denominator, the LCD. Well, when you have an LCD and you want to find the LCD, okay, it's very simple as long as you remember the LCM. When you know the common denominator, you want to convert or express the given fractions as equivalent fractions. What does that mean? Well, let's find the LCD of each set of fractions, then convert each fraction. So first of all, 12 and 15. Okay, what is the LCD? What is the least common denominator? Well, let's find out. Here's 12, here's 15. Let's break this down. 12 is 3 times 4. 2 times 2 is where 4 comes from. That's the prime factorization. And this is 15 is 3 times 5. So my GCF, a 3 and a 3 comes out as a 3. So that's my GCF. I'm looking for my LCD, which is my LCM. So my LCD is the GCF of 3 times the leftover prime of 2 and the other leftover prime of 5. So the LCM is 3 to 30. Okay? I hope that makes sense. I made a mistake here, guys. It is not 30. I was looking at that, I said, that doesn't make sense. Yes, there was a 2 and a 5, but I forgot that there was another 2 that had not been taken out. So it's the GCF times the leftover primes. So the LCD is now going to be 60. Okay, sorry about that. So now, we got the LCD. How do I convert these denominators? Well, we convert them by multiplying the same value to the numerator and denominator. So I know that 5/12, we want that to become something over 60. Well, how do I get from 12 to 60? 12 times 5 is 60. Whatever I multiply to the denominator, I must multiply to the numerator. So I'm going to have 25/60. I know that I want to turn 4/15 into something over 60. What did I multiply to 15 to get to 60? Well, I multiplied by 4. Whatever I multiply to the denominator, I must multiply to the numerator, so I have 16/60. And now what I did is I just prepared these two fractions to be able to be added or subtracted. But we'll get to that in a few days. But this is just all preparing you for adding and subtracting fractions later on. Now, we just finished using the concept of equivalent fractions. Equivalent fractions are fractions that have the same value with a different appearance. 1/2 is the same thing as 3/6, which is the same thing as 4/8. How? How does that work? Well, to find equivalent fractions, simply multiply or divide the same value to both the numerator and denominator. When you divide by the same value, though, my friends, you are finding equivalent fractions, but you are also reducing those fractions to lowest terms. For example, find 3 equivalent fractions for 3/5. There's nothing that I can divide into both 3 and 5, so I'm going to multiply this by 2/2, which will give me 6/10. Then I'm going to multiply that by 3/3, which can give me 9/15. And then I'm going to multiply by 4/4, which is going to give me 12/20. All of these are equivalent fractions. Why? Because I multiplied 3/5 I multiplied the same number to both the numerator and denominator of 3/5. When they tell you to reduce, they're just trying to tell you to find an equivalent fraction once again. So I have 24/40. But when they want you to reduce to lowest terms, they don't want you to multiply, because that's just going to get your fraction more complicated and more complicated. They want you to reduce. They want you to divide common factors. So what's a common factor to both 24 and 40? Let's start with 4. If I divide by 4/4, 24 divided by 4 is 6. 40 divided by 4 is 10. Let's do another one. I should have done 8, but I wanted to show you that you could do this a lot of different ways. I can still go further. I can divide a 2 to both top and bottom. So 6/10 becomes 3/5. And now that is all the way reduced to lowest terms. So when you want to find equivalent fractions, multiply the same number to both the numerator and denominator. When you want to reduce a fraction to lowest terms, divide the denominator and the numerator by the same value. As long as you multiply or divide the numerator and denominator by the same value, they will be equivalent fractions. Rounding decimals. Okay, we're going to wrap it up with rounding decimals today. Please remember that the decimal here, that is represented by the word and. Okay? So this number that I have here would realistically be read as 9,605,872 and 145,673 millionths. You always end with the last place value. Why did I give you these? I just wanted you to remember that you have the tenths place, it's the first decimal, hundredths, thousandths, 10,000ths, 100,000ths, millionths. All of the decimal place values end with a TH. Now, in order to round decimals, follow the same procedures as rounding whole numbers. 1. Find the place value you are rounding to. 2. Look at the number to the right of the number being rounded. If that number is less than 5, then that number stays the same. And every number to the right of it drops. If that number is greater than or equal to 5, then the number goes up by one value and everything to its right drops. Okay? Hope that makes sense. Let's go ahead and do a couple practice problems. Round each number to the given place value. So round 0.14 to the tenths place. The tenths place is right here. So I'm going to look at the number to the right. That's a 4. It's less than 5. So it stays the same, but the 4 drops. The number to the right of the value being rounded drops. 1.397, rounded to the hundredths. The hundredths in this case, let me go ahead. Sorry about that. Let me move this because now it's going to be a little bit difficult. The hundredths place here is right here, the 9. I look at the number to the right. That number is a 7. That is larger than 5. So this 9 is going to go up by 1, becoming a 0. I'm going to have to borrow the 1 that it went up to because it went up by 10. So this is going to become 1.4. 690 thousandths, rounded to the hundredths place. Well, this tenths, hundredths is the 0. We look at the number to the right, that's a 3. So that's less than 5. So that drops, this stays the same. So it's just 690. 14 3,983 10,000ths. I want you to round it to the thousands place. Well, the thousands place is right here. I look at the number to the right of the value being rounded. That is less than 5. It stays the same. The 3 drops. So I've got 14.398. I hope that made sense. I hope that refreshed your memories. Thank you very much, and I hope you learned a lot. Have a great day. Take care. Bye-bye.